So here is our problem on the Bugatti Veyron, and on the right hand side I extracted the important information, and we can see that we actually have two parts into that problem and two unknown variables, which are the scale speed and the time for the model car to travel 16 meters. Let's look at the scale speed, and we know that the scale model is 1/8. So what is 1/8? It's actually a ratio. It's, in other terms, a proportional relationship between two parts. Here, the model car over the actual car. And if we put that into English term, we've got one part of the model car is equivalent to 8 parts of the actual car, or is related to 8 parts of the actual car. So let's put that in a table and look at the scale factor. And depending on the direction of the arrow, we would have a multiplication or a division. So between actual and model car, so going from the bottom to the top, the scale factor is 1/8. So if we extend that example, but first look at the scale factor of 1/8. So we know that a ratio is equivalent to actually a division. So here we have 1 divided by 8. And if we put that in a decimal number, we end up with 0.125. So we can use that decimal number to actually this time multiply instead of divide our actual part to get the model part. So here we will get 6.25 and etc. with the other numbers. So this is our between strategy. We could also look at the within strategy, so within the part of the actual car, for instance. We could see that we can multiply by 2, by 4, by 5, or divide it by 2. And similar thing would happen for the model part of the car. So now let's take our speed, actual speed of 428, and apply the between strategy or the within strategy. And in either case, we end up with 53.5 kilometers per hour. We can put all that together in a graph, and we have actually a linear relationship or linear regression. And again, we see here our between strategy, and here we have actually had the equation that gives us that linear relationship between the model car, which is equal to 0.125 multiplied by actual car. Or we can see our within strategy, so what happened on the x-axis would also happen on the y-axis. And again, if we take 428 and we applied either strategy, here the between, and here is the within strategy, we end up with a scale speed of 53.5 kilometers per hour for our model car. So now let's look at the distance to travel for our model car and the time it would take. And here we have a notion of time, and that notion of time, we see it in the speed. And the speed, what is it? It's actually a rate or ratio that involves time. And if we put that in English term, we have kilometer or distance per hour, so time or distance per unit of time. So again, yes, let's use a table. We've got the distance on the left and the time on the right. First of all, we need to have uniformity with the units. So let's transform kilometers in meters by multiplying by 1,000. And I doubt that we will have hours as a unit of time for such short distances. Let's transform in second by multiplying by 3600. Now, let's look at our between strategy, and we actually have a scale factor of 16 over 53,500, or here we can also have the within strategy with a scale factor of 3600 over 53,500. And if we apply those strategy, we end up with 1.08 second. Now let's look at the approach of cross multiplication, which is more a procedural approach. And we can transform our table into an equation, and on the left side we have our unknown variable, and on the left side we put together our known variable. And what's interesting is we can see that the scale factor, we actually saw it as a within strategy in the previous slide. And of course we end up with 1.08 second. This is the time they would take for our model car to travel 16 meters. What's interesting in this exercise is that we actually develop the conceptual understanding first by applying within and between strategy to actually explain what a procedural strategy would be. And the procedural strategy would just be apply the rule of cross multiplication, but there's an explanation beyond that, and that was actually given by the between and within strategy. Thank you.